Hey, good morning, Calculus 1 students. We are in the middle of Chapter 5. We learned how to integrate, do antiderivatives. I'm still in this section 5.4 has a few more ideas I'd like to try to get out. The main idea was the fundamental theorem of calculus. You learned how to do a definite integral. Find the antiderivative, evaluate it. Anyway, there's a couple more ideas. There's this mean value theorem for integrals. It says this, it says if f of x is continuous on a closed interval a to b, from a to b, then there exists a number c in that interval a to b such that the integral from a to b of f of x dx equals f of c times b minus a. Wow, the mean value theorem for integrals. Let me try to interpret that a little bit for you. I'll draw a picture. So I've got a function that's continuous. I'm working on this closed interval from a to b. And then, and you know what this means. This side of the equation is the area under the curve, of f of x from a to b. So that would be the entire area. And what they're saying here is that there's this mean value theorem. What they're saying is there's a number c that lives in here, such that, maybe I could have drawn a better picture, such that if you plug this number c into the function, you get a height, f of c. And look what happens. If you take that height, that y value, f of c, and multiply it by that width, b minus a, so it's like we make one big rectangle instead of a bunch of little rectangles. It's like we got this width from b to a to b, that width, b minus a, multiplied by a height gives us that one width times that one height gives us the area. So there's a number c that lives on the x-axis. If you plug it into the function, you get the y value, f of c, and that y value is some kind of an average height. Where the area of that rectangle equals the area under the curve. That's a height, that's a width. So that's cool. There's guaranteed to be one place where that happens. And so this height that I'm really looking for, it says the theorem guarantees this number c on the x-axis, but I'm really tend to look for this y value, f of c. And we call that the average value, the average height, the average value of the function. It's called the average value of the function. There's some homework questions that ask for the average value. By the way, the average value, the mean value theorem, so if I solve for f of c, the average value is that f of c. And so what is it? It's this integral divided by this width. It's the area divided by this width will give you the height. So the way I divide by that width is I put 1 over b minus a in front of this integral from a to b, f of x dx. So this is the mean value theorem, but it leads quickly to finding the average value. And that's usually the question I like. I like that question. Find the average value of the function. Find that average height. Let's do a problem. I made up a problem. So to do a problem, I'm going to have to erase this. So I'm going to erase this. I'll leave that there. I want to do this function. F of x equals 1 plus the square root of x. I want to give a closed interval, 0 to 9. I could draw a picture of it, but I'm asking for the average value. Please find the average value. So that's this y value. That's this f of c. So here I go. According to this formula, I mean, I don't really need a picture. I just need to try to find f of c, the average value of the function on this interval. I would, in front here, I would do 1 over b minus a. So 1 over 9 minus 0. Of course, that's a 9, a 1/9. 1/9, 9 minus 0, times the integral from 0 to 9 of this function, 1 plus the square root of x. If you don't mind, I'm going to write that as x to the 1/2. Okay, that's what I got to do. So in other words, I do the integral and then I divide by 9. I do the integral, I find the area, and I divide by the width to get the height. But that's okay. You can think of it however you want. Here I go. There's a 1/9 in front of this integral. And I'm going to try to do this integral. Let's see, I'm sorry. Let's go ahead and integrate it. You know, by the way, notationally, this says please integrate this function. And when you do integrate this function, you lose this notation. That shouldn't, the integral symbol shouldn't be there. I'm integrating the 1, that's an x. When you integrate the x to the 1/2, the power rule says you add 1 to the power. That's x to the 3/2. You divide by 3/2. Dividing by 3/2, I want to just multiply by 2/3. And then I evaluate from 0 to 9. I evaluate this from 0 to 9. All right, here we go. That's a 1/9. When you plug in the 9, that's a 9. That's a 2/3 times 9 to the 3/2 minus a 1/9. And then you're plugging in the 0. That's a 0. That's a 0. So that contributes nothing to the problem, the answer here. Here we go. That's 1/9 times 9 plus, hang on, this is the square root of 9, which is 3. Cubed is 27. 2/3 of 27 is 18. So that's what this is. 18 plus 9, that's 27. Divided by 9, wow, the answer is 3. That's the average value. That's the answer. That's F of C. I think I would like to draw a picture of that. Let me get rid of that formula for you. Get rid of this formula. Let's draw a little picture of this. This function was 1 plus the square root of x. You know, it's that square root function shifted up 1. I know how to draw that. Your graphic calculator could help you. But there it is. There's a picture of this function. And I'm working from 0 to 9. So there you go. I'm working from 0 to 9. You know, when you plug a 9 in that function, the square root of 9 is 3 plus 1. That's a 4. So that's a height of 4. That's a 1. So I'm not exactly to scale here. Let me help make this a little better here. That's a 1. There's 2. There's 3. Okay. All right, so there's that picture. And what did we find? Oh, we found the y value. We found the average height, the average value of the function. It's almost like if you found every y value in the world and added them up. I mean, all the infinite y values, added them up and divided by how many you got, which is an infinite number. The average height, the average y value is 3. So if, like I said before, if you made a rectangle right there with a height of 3 and a width of 9, that would be the area under the curve. I guess that area was 27. Yeah, before you divided by 9. Okay, all right. Some of the homework problems want you to find that C value, guaranteed by the mean value theorem. There is a C value here. So now you're looking for the x value when the function has a y value of 3. So that's not difficult. That's algebra. I'm looking for when the function has a y value of 3. I'm looking for that x value. So that's easy. Subtract 1, the square root of x equals 2. Square both sides, x is 4. So the C value guaranteed by the mean value theorem is 4. C equals 4 is the x value that you plug into the function to get that average height. All right, cool. That took me a while. There's like I said, there's a few other things I want to say in 5.4. I think I'll get to another video here.